This is a problem based on electromagnetic induction, but I'm planning to solve few 10 to 15 problems on electromagnetic induction, especially on self and mutual induction after this series, self and mutual induction, and then I will go through the problems of alternating current, and then I will move to the playlist of optics. So this is going to take 3 or 4 more days before I can complete this section. So here is a problem at your screen. You can see here. This is the problem based on electromagnetic induction. So the problem is a circular wire loop of radius A. Its radius is A, and not given in the picture, and resistance R. Its resistance is also given, and that is equal to R. Located in a uniform constant magnetic field with the induction B, rotates uniformly around its diameter perpendicular to the magnetic field, of course, with angular velocity omega is supposed to be at a constant, neglecting the inductance of the loop. So this is the most important information about this problem. Find the average mechanical power required to maintain rotation. That means during in rotation it is losing something, कुछ न कुछ तो lose कर ही रहा. So what can it lose? You can see here that at any time t, the angle between magnetic field vector and its area vector is something given here, phi or psi t. This is the angle, and of course this angle can be written as this angle phi t can be written as omega t in time t, because it's also rotating at constant velocity, so both can be related. इन दोनों को relate कर सकते हैं, and it's changing. The angle between magnetic field vector and the area vector is changing with respect to time. With time, that means flux is changing. Flux is changing. That means an EMF has been induced in this loop, and so it is losing power. The power it is losing is simply E square upon R, E square upon R resistance. Of course, B square by R or I square R is the result. I am not going to find the current, resulting current, because I can easily find the induced EMF. And so after then E square by R is the power losing, so I need to find the value of average value of E square by R, and the problem will be solved. So I'm going to solve it. So I'm going to remove this picture. I don't need this as well, because we have something like this, that phi or psi was given, not phi exactly, this was psi. So this is the angle between magnetic field and the area vector, and this angle can be written in terms of angular velocity of the loop is equal to omega t, and then the flux, you know, is B dot S, that means Bs cos psi t, and B is simply B. I think B was simply B, and if it is B naught, I don't have a problem. Area is pi A square. A was the radius of the loop, and this psi t can be written as omega t. So I got the flux, and then I will need the induced EMF in the loop, that is del phi t by dt, and that I got minus sign can be compensated here, b pi a square omega sine omega t. This is the basic differentiation you can do. And so the power is E square upon R, that is V square pi a raised to 4 pi square also. That means we should write simply as b by a square omega square sine square omega t divided by r. And so the average value of this, to find the average value of this, you simply need to find the average value of sine square theta, and sine square theta plus cos square theta is equal to 1, and sine square theta and cos square theta both have same average value in one time period. That means twice of average value of sine square theta is equal to 1. That means average value of sine square theta is half. So the answer is 1 by 2 or b by a square omega whole square. This is the answer. Thank you very much for watching or not watching actually.